wire messages to have a one success.
We can go out here. It works on the first try. Tohle nám funguje. Budeme potřebovat zvuk, takže to jenom stačí připojit?
Jo, je připojené. Tady se dá regulovat, jo?
Jo.
To je zvuk z počítače.
Dobře. You've got 50 minutes, so I will be guiding you to like 40 minutes to left like 10 minutes for questions and answers. So is it okay?
Yeah, it's okay. We've got some flexibility,
Okay.
so if we're running late, we'll just stop.
And for the microphone, there is microphone for recording. There is no microphone for the room, so it would be great if we would be talking like in 1.5, 2 meters from this one.
1.5 to 2 meters?
Yeah.
Okay.
Like not going on to the other side of the room.
Okay. Oh yeah.
If you would be talking.
Sure.
And I guess you've got 12, so in a minute we can start, I guess.
Okay.
Is it what you want to see? Okay.
What's that?
Is it start of your presentation?
No. I'm trying to. I need to bring
So
it up.
you need some more minutes, eh?
Yeah, just a
Okay.
couple minutes.
So I will wait.
Okay.
F11.
Okay.
Yeah, full screen.
All right. Yep.
So welcome Richard and Lukáš, who will be presenting you something uncommon about logging.
All right. Hello. My name is Rich Meganson. This is Lukáš Volčák. We're working on a logging stack. In case you were wondering what is a log and what isn't a log, we prepared a short video that should help explain that.
Yes, log. All kids love log. Log from Buramo.
So that's not what we're talking about. You may recognize that. So that's not what we're talking about. So why uncommon logging? So why is it uncommon? Logging is commonly an afterthought. It's stuck on at the end. We're trying to make it an equal partner in the application platform. We're trying to enable distributed logging of cloud-based services. Most developers just figure they'll use the logging APIs provided by the operating system or the platform, assuming they'll figure out how to store and use those logs at some later time. Usually by cobbling together a logging solution from bits and pieces of some sort of logging stack. this often doesn't end well, and it misses an opportunity to make really good use of the data. So we will, in this presentation, we will present what we've been working on, including some video demonstrations. So this is the world of cloud and microservices today. You have this complex ecosystem of all these horizontal and vertical layers all integrated with each other. So the amount of digital exhaust produced by all of these services and platforms is daunting to manage and understand. It's difficult to answer questions from users, such as, what's wrong with my application? Somebody logged into the system and did some administrative action, and now something is broken. How do I trace back my problem back to what that guy did when he logged in? And how can I proactively monitor my systems? So these are some of the objectives we want to achieve with our project. We want to be able to collect logs from distributed services running in the cloud in a secure and reliable way. We need to have a data model that we can use to describe data from many different sources. We want to have a clear definition of fields used commonly among all of these systems, but we want to also give services the ability to define their own fields for their own service-specific metadata. We want to support multi-tenancy so that users can only view logs which they're allowed to see. We also want to support federated authentication. So for example, if you've configured OpenStack to send logs to our logging service, we want you to be able to log in to the visualization part with your OpenStack credentials. We don't want you to have to configure multiple credential stores. We want to integrate well with Red Hat products and their upstream products, such as RDO, Overt, OpenShift Origin, Manage IQ. We want to work with subject matter experts in those projects, which would be you guys, to figure out how you want to represent your data, what the actual data coming out of your log means, how it's meaningful to you, and how it might be meaningful to correlate with other services as well. We have to be scalable. We have to be elastic. So we have to be able to scale up and down as needed for burst situations, things like that. But at the same time, we also want to provide different tiers. So if you come to us with your requirements, we can have something that's already ready to go for your particular deployment scenario. We want to enable other uses of this data. So we just don't want it to go into a warehouse and sit there and do nothing. We want to enable the use of big data applications and any other applications that the user might have in mind for their logging data. And we also want it to be all open source. We want to identify open source components that will fulfill our requirements, work with those upstreams, and also work out in the open, in an open way. So how are we doing logging? So this is a picture of the current architecture that we have today with sort of the components abstracted. So on the left here, we have all these hosts. They have all application services, all these things that are creating logs, going into log files, the journal, or syslog. So we have a collector that collects logs from all of these sources and sends them into a central logging system. So the logging system consists of, on the front end, a load balancer. And these boxes represent what we call their log aggregators, multiplexers, normalizers that massage the data as needed and send to a data warehouse. Then we have a visualization component that's able to do queries of the data warehouse and display graphs and charts. And then we want to have monitoring of all these components, so we'll know when administration is needed, when scaling is needed, things like that. So this is the current architecture with the components that we've selected. So for the logging system, we're using the OpenShift platform. The OpenShift platform has, the integration services team for OpenShift already developed a logging stack based on FluentD, Elasticsearch, and Kibana that we're making use of. So this provides us the ability to deploy, manage, and scale the containerized logging components, as well as take advantage of some of the things built into OpenShift and Kubernetes, such as flexible storage options, load balancing, and high availability. So we're using FluentD both as the collector here and as the normalizer here. It works well in both situations. This HA proxy component is the routing service component that's provided by OpenShift platform. So we're using Elasticsearch as the data store, and we're using Kibana for visualization. So we've developed this tool called Watches, or Watch ES, that we're using for monitoring of Elasticsearch. And we're still working on the components to monitor FluentD and monitor Kibana. Okay, so FluentD is both the collector and the normalizer aggregator. So FluentD is a Ruby-based log agent. The configuration for FluentD is very similar to Apache config files, so it's familiar to admins and developers. So you can use Ruby code in the configuration. So here's an example of some Ruby code embedded in the configuration. The code between the $, open brace, and close brace is some Ruby code that converts the timestamp coming in from journal into the timestamp that we want to use in logging. So the protocol that FluentD uses is the secure forward protocol. It uses TLS. It has built-in load balancing and failover. And it uses the message pack format to compact on the wire to reduce network traffic. So FluentD has hundreds of plugins available, literally hundreds, for virtually any kind of input, output, and processing you would ever want to do. But if it doesn't, then it's very easy to write plugins of your own in Ruby, even if you have very minimal Ruby experience. So one of the reasons we chose FluentD was because there was already a Fabricate.io plugin that was able to get Kubernetes metadata from container log events and annotate those log events. Another reason was because the OpenStack Ops Tools team had already chosen FluentD for their reference architecture, so they already had some literature and guidance to provide for that. FluentD also had all of the inputs, outputs, and filtering that we needed out of the box, such as HTTP, journal, and Elasticsearch. We would also like to support rsyslog too, so that we are still investigating the use of rsyslog. So Elasticsearch is what we're using as our data warehouse. It's a widely used Java-based search engine. It's based on Apache Lucene, which gives it excellent full text search capability. It's also good as a time series database. It's not as good as some databases that are dedicated to time series data, but it gives us a nice balance of features between performance and other things that we need to use. We use an Elasticsearch plugin, open source plugin called SearchGuard, and this gives us the TLS authorization and access control. The Fabricate.io team also developed an OpenShift Elasticsearch plugin that works with OpenShift for authentication, authorization, and access control, and that's what gives us the ability to do multi-tenancy. The OpenStack Ops Tools team also had chosen Elasticsearch for their reference logging architecture, and other teams such as Overt had already decided that they wanted to use Elasticsearch for logging and their metrics store. And the last component is Curator. So right now, it's provided by Elasticsearch, and it is what does our log trimming and deletion. All right, and for the visualization component, we're using Kibana. Kibana is a Node.js-based application. It's very tightly coupled with Elasticsearch, so it just works right out of the box with Elasticsearch. The OpenShift Elasticsearch plugin also works in conjunction with Kibana. It pre-populates some of the Kibana configuration you need when you log in, and it creates index aliases, such as the all alias that's used by administrators. We're currently investigating the use of Grafana and ManageIQ as a user interface front end as well. So here's a detail of the logging architecture showing what's going on in the logging system. So the logging system itself is based on the OpenShift platform, so that gives us a lot of the fundamental capabilities that we need. So on the left side, all the log messages from the host come in via FluentD secure forward, and they go into the multiplexer service route HA proxy that's provided by the OpenShift platform. So this distributes that load among several aggregators FluentD. For messages that are container logs, FluentD will go out using the plugin and get the Kubernetes metadata in the OpenShift API service and annotate those logs. The connections come into the SearchGuard plugin before they go into the Elasticsearch data store. So on the browser side, the browser first goes to the Kibana pod, which is running an auth proxy container. That goes out to OpenShift to do the authentication, and then it annotates the request with token and user ID headers. So those are passed to Kibana, and then Kibana passes those through with that information and the query to Elasticsearch. The first thing that hits there is the OpenShift Elasticsearch plugin. So that will authenticate the token, make sure the token is still valid. And then it will go out to the OpenShift API. So we get the user ID. We need also to know what the user's roles and projects are, so we can set up access control for that user. All right, so one of the big challenges is correlation. So for example, if you're running OpenShift on OpenStack, so how do you correlate the errors you see in your containerized applications with things that may be happening at the OpenShift layer, or below that the OpenStack layer, or below that the operating system layer? How do you correlate login sessions with problems that might have been caused by that admin logging into the system and changing some configuration? What do fields mean? Do they have different meanings depending on what application is writing it? So when I get a hostname field from OpenStack, does it mean the same thing as a hostname field from OpenShift? And time. Time is an important datum for correlation. So we need to ensure that we have a good global, consistent, and high-resolution timestamp. So the solution is a common data model. So the common data model provides a rigorous definition of commonly used fields, such as hostname and timestamp. Plus, it provides the ability to have application service-specific metadata fields in such a way as to avoid conflicting definitions. So what we're trying to do is eliminate conflicts and inconsistencies in log data. We're trying to precisely define fields so you always know what a particular field means. It provides hierarchical namespaces for service-specific metadata. And we want to provide concrete recipes for formatting data in collectors so that you can automatically know what your FluentD configuration or rsyslog configuration should look like. We're able to generate Elasticsearch index templates and documents. And we have this YAML format that we use to produce all of these things. So for example, on the left side is an example of an Elasticsearch index template. And on the right side is an example of ASCII documentation that are produced from this same definition format. And so here's an example of different namespaces. So on the left, I've got a namespace called Kubernetes. And on the right, I've got a namespace .overt. Both define a field called level, but it means different things in different namespaces. So when I collect the data, for example, in a Kibana query, I can refer to one as Kubernetes.level and the other as overt.level, and there's no conflict. Another challenge is packaging. There are many, many packages to maintain. So FluentD and all the plugins that we want to use is about 35 runtime dependencies and about 90 build time dependencies. Another challenge with FluentD is because it's Ruby, keeping up with the FluentD versions and the Ruby versions. For example, the next version of FluentD only supports Ruby 2.1 and later, but RHEL 7, EL 7, CentOS 7 only has Ruby 2.0 standard. So this is one of the reasons why we like containers, is because we can containerize all of these things so they don't conflict with other. Or we could use software collections. Elasticsearch 2.x introduced this concept called jar hell, which is quite strict about what versions of plugins and dependencies can be used. Elasticsearch plugins have to keep versions in sync with every Elasticsearch release. So when Elasticsearch releases a Z-stream, all of the plugins also have to bump the Z-stream version of that dependency in their Maven POM file. Kibana uses Node.js, NPM modules, libuv, V8, so And this is one of the great things about using containers, because we can keep all of these separate services self-contained and avoid problems with interdependencies with other components. So it takes a lot of manpower and automation to keep up with all of these versions and dependencies. So multi-tenancy. Our multi-tenancy implementation relies on an Elasticsearch index naming scheme, SearchGuard for index level security, and the OpenShift Elasticsearch plugin to provide the information needed to map the user's roles and namespace membership to the Elasticsearch index name. So for example, you can have an index called .operations that's only visible to logging administrators, and then indices matching this project.name are visible to members of that project namespace with that name. So when a project wants to send logs to the central logging service, the logging administrator will create a namespace for that project. And then we'll assign users from that project to be able to act roles within that namespace so they can access the logs. So we're currently using OpenID Connect for federation, so that if you log into your system and you acquire an OpenID Connect token, you can use that same token to authenticate to Kibana. So there's also physical security as well. So let's say you just want to keep your operations data completely physically separate from everything else. Well, you can create a separate operations cluster just for your operations data and have the data that you want users to have visible in a completely separate cluster that only they can access. So we're currently investigating if and how we can use federated groups and roles too. So some of the other challenges we have is languages. So FluentD is written in Ruby, Elasticsearch is Java, Kibana is JavaScript, Curator and some of the other bits are in Python, OpenShift is in Go, so there's quite a bit of things that you need to be familiar with in order to work on this. The complexity, there's just many moving parts. There's a lot of stuff to monitor, maintain, and administer. So we're looking at integration with monitoring systems. So we can know, oh, we're running low on disk, we need to add more storage for Elasticsearch. Our FluentDs are way behind, we're getting back pressure, we need to scale those up, things like that. Security is another big challenge. So all of these public-facing things have certificates and keys. FluentD Secure Forward has a shared secret. We need to be able to securely generate, distribute, and update all of these certificates and keys and shared secrets. So we're looking at integration with things like IPA, Free IPA, CertMonger, Custodia, and Let's Encrypt. So our syslog. We would really like to be able to use our syslog with this. Our syslog has a number of advantages. Our syslog has this protocol called RELP, which is a highly reliable secure logging protocol. Our syslog is already part of the operating system. We're going to rebase our syslog to version 8 in RHEL 7.4, and that brings us very close to feature parity with what we are using with FluentD. Our syslog is also much more scalable and performs much better than FluentD. The problem with FluentD is that, with our syslog, is that we need to support more integrations. There's not nearly as many plugins as there are with FluentD. Also, our syslog has a lot of negative perceptions. People in the past have been turned off by its arcane config file format, which is much improved in later versions. And people have had bad experiences, perhaps, with our syslog that was in earlier versions of RHEL 5 and RHEL 6. We also want to correlate the log data with data from metrics and monitoring and even configuration events, because if you want a holistic view of what's going on, you need to correlate, CPU spikes with configuration data that may have caused that CPU spike with log messages that you're getting from various systems. So what we want to have is we want to have some sort of, pre-canned tiers of deployment for different customer use cases. And these are small, medium, and large. So small would be that you have a direct connection from the collector running on each host to Elasticsearch. And that's really only suitable for very small deployments. And it also means you have to have all the normalization logic in the FluentD running on each host. But it is simple. There's much fewer moving parts, but it's really only suitable for small deployments. So the medium size is the slide I showed before, where you have a scalable farm of these FluentD aggregator normalizers. And it's applicable for a wide variety of deployments. And then for the large sizes, we would like to introduce a message queue. Some of our very largest customers are already using message queues for similar applications, so we want to be able to also use that. And this is what we think it might look like with a message queue. So the collectors write data into, let's say, a topic that's a raw data topic. In this scenario, we don't have an HA proxy. We assume the message queue is providing that capability for us. So the normalizers would read data off the raw topics and normalize them. And when they write it out, they write out the normalized data both to the data warehouse and back to the message queue in a normalized topic. So the normalized topic could be used for big data analysis, archival, tailing, monitoring, and lots of other uses as well. So one of the problems with the queue, the challenges, is that it introduces more complexity. So now you've got another thing that you need certificates for, and you need to make sure that they're securely distributed to. Access control. What if we want to have different topics that have different levels of access control for each topic? How do we do that? So I'll turn it over to Lukasz.
Yeah, thanks. So I will very quickly talk about performance. That's one of the changes. We are focusing on performance as well. What's the problems with performance? So first of all, if you think about it, it's funny, but it's the first change is to really get the hardware and something like that to be able to do performance monitoring. So what I mean is, for example, some users can have very high quality networking or hardware, and it makes a difference in performance. So that's kind of a change that is probably solved by budget. But out of that, we are also focusing on collecting the data and really trying to make sense of that. So if you think about what you have seen, how our logging architecture looks like, most of the pieces are quite a simple things, like tools that do one thing very well. So it's not that hard to tune them. But Elasticsearch is an exception. It's a very complex thing, and we need to take it very carefully. So the good thing about Elasticsearch is that it can export a lot of internal statistics. And as Rich mentioned, we built a tool called Watches that can pull all those statistics from Elasticsearch. And then we are collaborating with our performance department that has their own set of tools and ways how they can measure performance. And we are trying to integrate the data from Elasticsearch with their tooling. So specifically, they use a tool called eBench. Maybe if there is someone from the performance department, they can tell you more details about it. But why this is important? It's important to see how Elasticsearch is doing in context of other, in context of other components in the system. So, for example, if you see that Elasticsearch uses a lot of CPU, but at the same time the other component is also requiring a lot of CPU, it's important to know it. So it's not enough to look only on Elasticsearch performance characteristics. You need to see it in context. If we have enough time in the end, I can show some examples of that. So what we want to achieve with performance is that we want to give users good recommendations about hardware sizing and configurations, and possibly to provide good starting defaults. And what we are also looking at is further using the curator tool to optimize the existing indices, or trimming the size of the indices. By the way, when I mentioned pbench, we already use it when we were comparing performance of rsyslog and FluentD, and this tool was very handy for us to learn that rsyslog is way better in performance. That's why we want to use it. So I think I can hand it back to the Rach.
Thanks, Lukasz. So a related project to logging is session recording, which is also called T-log. So this is what gives you the ability to track login sessions. And we're working with the T-log team to develop a schema for the common data model so that we can log that data with all of our other data. Another project from the T-log team is AU Shape, which takes audit log data and formats it into a format that's more readily consumable by logging systems. So we're also working with them to develop a schema for the common data model. Okay, so now I think we've got plenty of time. So we've got some demonstrations. So the first demonstration is a demonstration of Kibana. Oh, I'm sorry, of installation. So all right, so we use OpenShift Ansible to install. So if you set hosted logging deploy equal true, it will deploy all of the logging components. You can also set things such as the public host name that you want to use for Kibana to have access externally. And there are many, many different parameters that you can set. There's a lot of Elasticsearch parameters that you can set here, as well as other parameters as well. So for this demo, I've just done a single node deployment, which is an all-in-one. So we use the typical, this is using OpenShift Ansible from upstream source and using git branch release 1.4 for origin 1.4. So basically you do Ansible playbook with the inventory and the playbook. And it goes through. And there's your scrolling Ansible -v output. So fast forward to the end where the logging happens. So there is a task called deploy logging. And this is what does all the logging tasks. Starts all the services, or runs the deployer, which starts all the services such as Elasticsearch, Kibana, Curator, and it waits for them to come up, so it's got some sort of liveness, readiness going on. And it starts FluentD. That's already integrated in the OpenShift Ansible installer, yes.
Does that create like a separate namespace for it, or is that?
Yes, and so it creates a separate thing called separate project namespace called logging for deploying the logging components, and that's flexible too. You don't have to use that, but that's the default. Okay. So. Okay, so the next demonstration is a demonstration of multi-tenancy. All right, so what we're going to do is we're going to create a log admin user called log admin, and we're going to assign him the role cluster admin. You can also use cluster reader as well if you want to have a log admin that is not able to change things. All right, so we log into Kibana. So the log into Kibana, you can see it redirects to OpenShift origin. So it's actually going to it's using the OpenShift OAuth provider. And then we get redirected back to Kibana. And this is the usual Discover tab in Kibana. So if we go to Settings, we can look at our index patterns up here. We can see that we have access to the .operations index as well as all the other indices that are available. So we logged in as the admin. We can see everything. We have access to everything. Log admin can see all. Okay, so now we're going to create a normal user with restricted log access. So we create a user called log user. So in order for that, so we created the log user, but we also need to assign that user roles within the namespace that we're using for this, which is just logging. So we log in. So we log back into OpenShift origin. This time we're logging into the OpenShift console as the log admin. So we'll go to the logging project. Resources membership. So there's no users right now. So we want to add the user log user. We want to assign that the role basic user. And view. So those roles will give that user the ability to view logs from the logging project. All right, so now we go back to Kibana. So this time we're going to log in as log user. And we can see that we have the index for project logging, which is the logs from our namespace. If we go to settings, we can see that we can't see any of the other indices. So that's how multi-tenancy works. So the third example is just to give a little bit of the flavor of what Kibana can do. Okay, so we're going to log into Kibana as our log user. Okay, so this gives us it comes up by default in the Discovery tab. And by default, it's the last 15 minutes of logs, so we're going to change that to view logs from the last 4 hours. And you can see at the bottom the graph changed to have a much wider scope and show many more logs. So the list of fields available to query is listed on the left-hand side. If you click on a field, it'll give you a quick count. It's kind of a nice shortcut view of how many logs, the top logs values for each of those fields. The level field is the syslog, 3 is error, 6 is info. So what we're going to do is we want to look at our container logs. We want to look at our pods. And we want to find all the pods that are emitting logs to standard error. So container pod logs that are emitting errors. So here's the list. So we've got quite a few logs that are emitting error logs. So if you click on a line below, you can sort of look at the record details. So you can see that we've got our Docker container ID, a bunch of fields for Kubernetes, the log message, which looks like it might be a problem. The level is 3. We can get there's our Kubernetes pod name, all the other metadata associated with that pod log. So another thing you can do here is look at the JSON representation of the log. And this is where you can see the structure of the common data model. So you can see that there's a Docker namespace, there's a Kubernetes namespace, there's a namespace for pipeline metadata. It's a good way to see what the logs look like when they are ingested by Elasticsearch. All right. So we're going to create a visualization. So we're just going to create a simple line chart. And we're going to start a new search, which is we're going to use the search that we just previously did. So for the x-axis, we're going to show an aggregation. We're going to show the date histogram. So we're going to use the timestamp as the date aggregation, and we'll do that by default. Kibana knows that if there's a field called timestamp, it should use that as the time axis. All right, that's our search that we used before. We want to do the same search. And there it is. So there's our graph. So the y-axis is the count of pods that have error log messages in the last accumulated 5 minutes. And you can see the graph is interactive, so it's really nice for being able to scroll around and see what's going on interactively. So we're going to save that, and we'll just call it pod errors. Okay, so now that we have a saved graph, we can use that to display on our dashboard. So right now our dashboard is empty, so let's add something. We can use our saved search, pod errors, and there it is. It shows up on our dashboard. And it's got the same interactive properties that we had previously. So we can resize it, move it around, do whatever we want, make our dashboard look as pretty as we want. Okay. All right, so next. We're running out of time. All right. Do you want to show this?
I'm not sure we have time for it.
All right.
So, we should definitely.
If there will be no questions, we can probably
Yeah, if there are no questions, we can show more
Sure.
stuff.
to give time for questions.
Yeah.
I don't know what
But still, we have something
Yeah,
to tell, right?
sure.
Maybe
All right.
the first question will be, can you show us?
All right, so who's making this possible? So there's a CentOS Ops Tools SIG, special interest group. So it's a common shared repository of packages, configurations, installations, and sort of best practices for how you deploy a logging service. We're working with other special interest groups in CentOS, such as Cloud, Platform as a Service, Vert, and others, to sort of share the wealth and spread the load of maintenance. It was started by the Cloud special interest groups. They had sort of formed an Ops Tools group, and then we decided that it's applicable to a wide variety of projects. And this also covers metrics and monitoring, so things like Sensu, CollectD, things like that. Some of the teams involved, so this logging platform, as I said, was started by the OpenShift Integration Services team and Fabric 8, which provides a lot of the other tools, such as the plugins. There's the VIQ team, which is Lukash and I and some other folks who are working on how tying this all together, deploying, and working on the common data model. There's also the performance team that we mentioned. They've been very helpful in being able to test logging at scale. And there's also the Overt, OpenStack, and TLog teams who are helping us test, integrate, and develop the product-specific data models. So where to find the code? So here's the typical GitHub links and IRC channels. All right, so we have a lot of time left for Q&A. So people asking really good questions. I have these special super CD DVD cases direct from the United States National Association of Governors. Very rare for people that still use CDs and DVDs. So if you ask a good question, you're going to get one of these. And please take them. Yes?
You have mentioned that you can get the dependency card. So do you have any way to package the FluentD collector for different OSs? For example, we do want deploy on RHEL 6, RHEL 7. We do not have Rogi. We do
Right, so the question was, do we have a way to package FluentD for platforms other than EL7 and, okay. Right now we don't, because we're very, enterprise Linux type centric, Fedora centric. So we would welcome, input from people that, might be able to give us some guidance and help us package for some of these other platforms.
How about getting FluentD agent on containers? Because
Right.
containers needs to be streamed, and
Right.
we are adding a lot of dependencies.
Right. So the question is, what about putting FluentD in a container? It's already in a container. We're already running it in a container. We're running it in a container that's in a Kubernetes OpenShift pod. So it may be possible to take that and make that container more generally applicable.
Another question.
Question? Yes.
We were talking about monitoring the logs of the system. Is there an API or some mechanism for the users without logging to the system to have some notifications like Nagix or some connectors?
Oh, so you're asking, are you talking about for the individual logging components, such as for Elasticsearch and FluentD? Or are you talking about how do we send Nagios messages into the logging system? The other way around.
So we have Kibana.
How do we monitor Kibana and Elasticsearch? Yeah, so we're currently, so the question was, what integrations for monitoring do we have with Elasticsearch and Kibana and things like that? Right now, we don't have anything yet. We're currently investigating that. For example, we saw that there's a collectd plugin for Elasticsearch that we might want to investigate. I know that we've got a lot of people that want to use Hawkular, so we're looking at ways of using Hawkular, and we would appreciate any help with Nagios or some other monitoring tool as well. Thank you. Yes.
I'm curious if you guys would be finding specific dashboards and reports
Yes.
for based on pod type. For example, if I'm running a bunch of Node.js pods, I can figure out what would be interesting for someone.
Right. So the question is, would we be interested in providing graphs and dashboards specific to certain applications? And the answer is yes. So that's another thing that we want to do is provide some pre-canned dashboards. We definitely want to provide dashboards for things that are common data fields, and we eventually want to get to the point where we can have application-specific dashboards as well. So we would need help from subject matter experts there. Are you sure?
My grandparents already have
Yes.
What's the strategy regarding alerts? One of the benefits of having Elastic is not just visualizing, but also generating alerts.
Right. So the question is, what about other uses of Elasticsearch, such as for generation of alerts? We're looking at a tool called ElastAlerts. So ElastAlerts is a tool that is able to query Elasticsearch and take action based on log events that are coming into Elasticsearch. We're also trying to figure out if we can integrate with things such as ManageIQ for alerting and Hawkular for alerting as well. We can't give these away. Questions?
I was wondering about the FluentD client side.
Yes?
See a challenge there with the changing Ruby version. Is that going to be containerized as well?
Yes. So for OpenShift deployment, it currently is containerized. We have some groups, however, that would rather not have to deal with the complexity of deploying a containerized FluentD service. So we're trying to figure out how best to support those groups, whether it's probably something like software collections. So you'll have to run the Ruby 2.3 or 2.4 software collection in order to deploy the latest FluentD, something like that. So yeah, we would prefer if everybody ran it on a container. It makes our life a lot easier, but some groups have expressed interest in not running it that way. And in fact, that's another reason why our syslog would be nice, because our syslog is already packaged RPM for the operating system. There's no conflicts because it's baked into RHEL, so that also simplifies our life. Yes?
In your presentation, you shared a lot of insight about the OpenShift infrastructure.
Yes.
And you have anticipated that all your organization, open source projects are following your path. Do you have any update about what's the state of integration of those kind of functionalities in Overt eventually?
So, I'm sorry, were you asking about Overt?
Yeah.
Okay, so the question is, can you give me an update about integration with Overt? We've been working quite closely with the Overt team, actually, the past couple of months, because they have expressed interest in using what we're providing as both a logging store and a metric store. We're working with them to figure out, to show them how the secure forward protocol is going to work, how they will use that to send logs, how to deploy it on top of Overt virtual machines. Because if they want to run it run logging in cluster versus out of cluster. And we're also working with Overt to develop to use the common data model and develop a data model for their statistics. Last question. Yes.
You mentioned our syslog.
Yes.
Our syslog has the capability of sending CEE messages. Have you heard about that?
Yes. Right. So CEE actually is sort of a subset of the common data model. The guys that designed the common data model have incorporated CEE into that data model as well.
Because we are actively using this, I'm quite satisfied. I was wondering how you feel about it.
Yeah, I mean, it's essentially a sort of a JSON data model that you can have. As far as I understand it, you can have your own fields. Is that correct? Mm-hmm. Yeah.
You can just ship some JSON string, and have our syslog
right. So there's actually, the common data model, I think, has a namespace. If it's not in there yet, it's planned to be in there for CEE.
It's not enforced that much.
I'm sorry?
It's not enforced that much on
Okay.
You can just say anything.
Okay. So I think the plan is that if you want to add CEE data to the logs, that will actually get either sent or converted into a CEE namespace. So you can have all the fields in CEE in such a way that some of the field names in CEE might conflict with some of the names in some of the other namespaces. So we don't want that to happen. So we want to make sure it's in its own separate namespace. Okay. All right. All right, so to say thank you, we've prepared a short video. Goodbye, folks. Between 3 and 4 today, sure. Yeah, but you would get by the front end. Yeah, sure. Yeah, absolutely. I'd appreciate that. Thanks, James.
adapter for HDMI. Hopefully it will work. We had some problems with similar things, so we will see.
Oh, you did?
Yes, yes. What was your name?
I have a VGA one.
I understand. Well, Robbie seems to know his stuff. Yeah. He's very helpful. So. Yeah, thank you. It was nice to meet you.
Do you need some help or?
Yes. I think it's
That
on
should
track.
be okay, yeah.
I've been pretty busy this past week, so I
And there is
sort of
VGA
catch up with him.
or DVI or HDMI. And we need to switch to HDMI.
So, are you interested?
And yeah, it looks like it's working now.
Okay, so, I've got a power process. That's from Ryan.
Asi by došel, no. Zvládneš to tady? There is no microphone. You need to talk loudly, but this is small room. And for recording, there's a microphone for recording. So it would be good if you don't go too far from it when you will be talking. And they run away with...
So,
How do I,
it's not secure system. Have you thought about using the RELP protocol?
We're doing UDP, it's not an issue for us, but it's good. But setting up queues